So here I have a cubic graph. It's the graph of y equals x plus 4 times x minus 1 times x minus 3. I've written it over here for you to see. So let's talk about increasing and decreasing parts of this graph, or increasing and decreasing functions. So remember, this we can think of, this equation for the graph, we can think of as a function. So we put an x value in, we get a value out. That's exactly the same as a function. So which parts of this graph are increasing and which parts of this graph are decreasing? So try and have a think about that and how it might tie into the idea of gradient and differentiation that we've been looking at. So if we take a look on the left-hand side of our graph here, and think about the gradient at each point on the curve. So we can imagine a gradient sloping here, touching this point here, and that there we know is a positive gradient. And this section here, this is still a positive gradient, and this here, this is just still slightly positive, but it's still a positive gradient, until we get to a point up here where we might say that the gradient is neither negative nor positive anymore, and it's just flat. It's just a gradient of 0. So if the gradient is greater than 0, so to the left of this point here, what we said was that was an increasing function. So if the gradient is positive, I am increasing in value from any point on the left of this highest peak here, any point on the left to there, my function is increasing, it's getting bigger. So for dy dx, for my gradient is greater than 0, I can say that the function is increasing. And let's think about this section to the right of it now. So slightly to the right, my gradient is now, at any point, my gradient is now sloping downwards. We can keep going, it's still sloping downwards until we get to here, where again we can say the gradient is neither positive nor negative, it's flat, it's equal to 0. So between these highest and lowest points here, my gradient is negative, and this function is getting smaller and smaller and smaller, so it's decreasing. It's a decreasing function between these 2 points. So when dy dx is less than 0, I say my function is decreasing. So those are the definitions of decreasing and increasing functions. If dy dx is greater than 0, the function is increasing, and if dy dx is less than 0, the function is decreasing. So we can see that to the right of this point here, our function is again getting bigger. So the gradient now is a positive gradient. So to the right of this point, my function is increasing. So you might come across a question that looks something like this. Define the region where the function is a decreasing function. How do we go about that? Well, before we set boundaries either side of our decreasing function section. So it was this point here and this point here. It was between these 2 points that our function was decreasing. It was between these 2 points where dy dx was less than 0. So it's important to remember that these 2 points are when dy dx is equal to 0. These are what we call minima and maxima. So they're the minimum or maximum points on my graph. So either side of this point here, the y values are going to be lower. So we call this a local maximum. It's not the biggest point on the entire graph, so if we continued up the right hand side here, we'd find points where the y value was greater than this point here, so it's just a local maximum. It just means that either side of it, the points are going to be lower than it. And so this point down here, this is what is called a local minimum. So the points to either side are going to be bigger than it. But obviously, if we continued this line downwards, we'd find points with a y value that was smaller than this point. That's why it's called a local minimum. And the special thing about these points is that their gradient is equal to 0. The dy dx at those 2 points is equal to 0. You can see that I've drawn the tangent at those 2 points. You can see it's a flat line, and we know the gradient of a flat line is 0. So using that information, we can now find these 2 points. I can take my function and I can differentiate it. So let's do that quickly. So let's expand this out. Let's do the front 2 brackets first. We've got x squared plus 3x minus 4. Now let's multiply by our second bracket. Okay, now we're at a form that we can differentiate. So let's do that. dy dx. We know the rules by now. We multiply down, so that's 3x squared, subtracting 1 from the power, plus 2x minus 13. So let's see, which points are going to be points where the gradient is equal to 0? Well, we can set, because we know that this expression is equal to the gradient, if the gradient is equal to 0, then this right-hand side, this 3x squared plus 2x minus 13 is going to be equal to 0. So this expression here can't be factorized, so I'm just going to do that quickly in my calculator. It's not a very nice answer, but let's take a look at it anyway. So x is equal to minus 1 plus or minus 2 root 10 over 3. So we've got 2 solutions here. We've got the positive and the negative of this root here. So one of them is going to be smaller than the other. And so we've got our 2 x values. We've got this x value here, and we've got this x value here. So this one here will be x is equal to minus 1 minus 2 root 10 over 3. And this one over here is going to be x is equal to minus 1 plus 2 root 10 over 3. And what we can say is that the function is decreasing when x is greater than this left-hand value and when x is less than this right-hand value. So what we've done is we've found the 2 points, the 2 boundary points of the decreasing section of this function. So this is a common question that you've come across, maybe not with numbers this mean, but hopefully this shows you how to find the increasing and decreasing parts of a function, and also what maxima and minima are as well.